A reciprocating compressor compresses refrigerant vapor in a cylinder using a piston. In a way, reciprocating compressors are like automobile engines. The pistons are directly driven through a wrist pin and connecting rod from a crankshaft. Depending on their size, reciprocating compressors may have one or more cylinders. Multiple cylinders may be arranged in line, opposed, or in a V. In each cylinder, reciprocating compressors have both a suction valve and a discharge valve. These valves give the compressor its ability to pump refrigerant vapor against a pressure difference. They are usually located in the head of the cylinder, in passages connected to the high or low pressure side of the system. Let's follow the compression process in a single-cylinder reciprocating compressor during one complete revolution of the crankshaft. Starting with the piston at the top of its stroke, or at top dead center, the piston begins to move downward as the crankshaft rotates. Because both valves are closed, the downward moving piston reduces the pressure in the cylinder. As the pressure in the cylinder falls below the low side pressure in the suction line, the pressure difference opens the suction valve, letting refrigerant vapor flow into the cylinder. The piston continues down and pulls in more vapor until the cylinder is filled with low-pressure vapor at the bottom of its stroke. Once past bottom dead center, the piston begins its upward stroke. The suction valve closes. As the piston moves up, it reduces the volume of the space in the cylinder, increasing the pressure of the vapor. When the pressure in the cylinder exceeds the high side pressure in the discharge line, the pressure difference pushes the discharge valve open, letting the compressed vapor flow out of the cylinder. This continues until the piston reaches the top of its stroke and most of the compressed vapor has been expelled into the discharge line. When the piston begins its downward stroke, the discharge valve closes. The complete cycle then repeats during each revolution of the crankshaft. This is the mechanical positive displacement vapor compression cycle using a reciprocating compressor. Let's examine the centrifugal compressor, which uses non-positive displacement vapor compression for compressing large amounts of refrigerant and are typically used in very large capacity cooling systems. A centrifugal compressor has three basic components: an impeller, a diffuser, and a volute casing. Large capacity centrifugal compressors may have two or more impellers or stages in the same casing. Centrifugal compressors are usually driven by hermetic electric motors. However, open-drive centrifugal compressors are also available for applications using steam turbine, gas turbine, or engine drives. The impeller is a rotating circular disc with curved blades that is driven at high speed by the electric motor. As the impeller rotates, it moves refrigerant vapor from the suction opening in its center to the outer edge using centrifugal force. The vapor enters the suction at a relatively low velocity and leaves the outer edge of the impeller at a high velocity. This means that the impeller transfers its rotational energy to the vapor, but high velocity does not relate to high static pressure. To achieve the desired pressure increase, or compression, the vapor must be slowed down, converting its velocity pressure to static pressure. That's where the diffuser comes in. As high-velocity vapor moves radially outward through the diffuser, the flow area increases, slowing the vapor and increasing the static pressure. Some centrifugal models have diffusers with vanes or pipes which change flow direction and further slow the vapor. The volute-shaped casing collects the slow-moving, high-pressure vapor from around the diffuser and conveys it to the discharge connection of the compressor. Inlet guide vanes control a centrifugal compressor's capacity. These movable vanes are located in the suction opening. With vanes turned fully open, the compressor produces its full cooling capacity. As the vanes are closed, they reduce refrigerant flow through the compressor, reducing the capacity of the refrigeration cycle. In addition, capacity control in a centrifugal compressor can also be obtained by changing the rotating speed. This concludes our segment on the mechanical non-positive displacement vapor compression cycle using a centrifugal compressor.
The inlet casing provides a smooth transition flow of air from the filters, through the silencers, and into the axial compressor. The inlet casing also provides access to the thrust bearing and the inlet journal bearing. Variable inlet guide vanes are located in the inlet casing directly in front of the first row of compressor blades. The vanes are used to regulate the amount of air entering the compressor. The circular operating ring actuates the guide vanes so that all vanes move in unison when opening or closing. Before each set of rotating blades is a set of stationary blades, or blade rings, that direct the air to the next set of rotating blades. The compressor blade rings have stationary airfoil-shaped vanes that direct the air to and from the rotating compressor blades. The rotating blades force the air into progressively smaller spaces as the air passes through the compressor. Heat of compression is generated in the air as it is passed through successive compressor stages. The compressor consists of 16 rows of individually removable rotating blades. Each blade is locked in place by a dovetail arrangement at the base of the blade. The rotor is made up of a bladed compressor spindle and a bladed turbine spindle that is bolted together to make one single shaft.